Okay, so in 5.5, it's conditions for a rhombus, rectangle, and square. In 5.4, on Friday, we said, here are the properties that come with these shapes. This one is just kind of that reverse of it. Here's the minimum you need to qualify it for this shape. Now, all of these are still parallelograms. That has not changed. These are all within the parallelogram family. But in order to go further, once it qualifies as a parallelogram, we have these options. What is not listed up here is 4 congruent sides, rhombus, 4 right angles, rectangle, and the combination of both to get you a square. These are the additional properties. Now, if you look at the property sheet on the back of your notes, these are kind of already there. They work to qualify it as the shape, but also they come with the shape. So they are kind of new. If you abbreviated it, that's fine. Just realize these are the qualifies to get to the shape. So, if diagonals of a parallelogram are perpendicular, you have a rhombus. You also have, if a diagonal bisects a pair of opposite angles, it is a rhombus. Now you have to, that one's tricky, because you do have to make sure it is also a parallelogram, just because it has that diagonal. Remember, all of these have to qualify to parallelogram first. 55 is your second one for a rectangle, and that is if diagonals are congruent. So, the key thing today is, here's a shape, what is it, and why? You have to make sure, again, unless it states otherwise, qualify it as a parallelogram. If it just says, here's a quadrilateral, we have to go through the process, but we'll see the difference between the two. We look up at the first two. Look up at the first two. Can you conclude that the parallelogram is a rhombus, rectangle, or square? The key thing is they've told us it is at least a parallelogram. If they said if it was a quadrilateral, we'd kind of be stuck on the first one in particular. Because there's no way in that picture to qualify it to a parallelogram. If you look at your properties that you have for parallelogram, there isn't one that works to that. We have a diagonal. It's bisecting an angle. Now, not enough to get to a parallelogram, but they give us that. So now it's there. Rhombus, rectangle, or square. What is it?
Rhombus.
Yeah, it is a rhombus. And then the more important part is we say why. You're not going to tell me it's because there's 4 congruent sides. Okay? Yes, that is what a rhombus has, but why is that one?
But it splits the angle of it too.
What splits?
Because opposite angles are congruent.
What's that line called from corner to corner?
Diagonal.
Diagonal bisects.
Because diagonal bisects opposite angles.
Yeah.
Okay, so it qualifies it. We get diagonals bisect angles. It works. We go to the second one. Okay? Now, we don't fall into the trap of it looks like it. It looks like it doesn't work. We know it's a parallelogram because they told us it. We know it's a parallelogram because the diagonals bisect each other. Does that make it a rectangle, though? Yeah, are these marked as congruent? No, they're not the same. So diagonals are not congruent. We know nothing about right angles, so rectangles out. Diagonals perpendicular, don't know that. Bisecting angles, don't know that. Side lengths congruent, don't know that. That's out. Our best name for this is just a parallelogram. Okay? Don't fall into the it looks like it trap. It's going to get you. On these types of problems, we can give you a variety that look like a rectangle. You've got to follow the rules.
For it to be a rectangle, it would have to have all statements.
If it was that,
okay, yeah.
It would be a rectangle.
Okay.
It's not. Okay?
And that's one of the proofs for parallelogram.
Well, that alone is diagonals bisect each other, and that'd be a parallelogram. Yeah. All right, we go down to the next set. Find the value of x. This is using the rules that we have. Which rule is it using for a rhombus?
Diagonals bisect each other.
Yeah, so 6x minus 9, 2x plus 39. Okay, we set them equal, we solve. Looks like 4x equals 48. X equals 12. If they asked us to plug it back in, we could and get those values. Maybe they had both diagonals and we had to go solve for extra angles, whatever it could be. But it comes back to that rule. Okay, rectangle. It's using the rule if rectangles are or diagonals are congruent. Again, make sure they're talking about the entire diagonals. MO and LN are the entire length. You will have questions come along that are only part of the diagonal. You'd either have to double or take half of the full. Make sure they're the corresponding parts. They do match. They are equal. It wasn't in this example, but they do come up. So we subtract 2x equals 20, x equals 10. We could plug that in. Friday we also looked at how if you know one angle in a rectangle, when they're bisected, you could find the rest. Same thing works for a rhombus. That's kind of using more of the properties for it. Right now we're just thinking qualifying.